Hi everyone, I'm Cheryl. In this problem, we're going to solve the inequality x squared is less than 3 minus 2x. And then we're going to graph the solution set. Whenever you're solving an inequality, the first thing you want to do is make sure that there's a 0 on one side of that inequality. Now, why would you want to do that? Well, if you're looking at an expression and it's either less than or greater than 0, you're talking about is the expression positive or negative. Let's take a look at a general example. Here I have a graph, and I'm looking at this section of the graph is negative because all the y values are below the x-axis. The next section, though, is positive. It's all above the x-axis. It's then below the x-axis, so it's negative. And in the next section, it's above the x-axis, so it's going to be positive. The last section is all below the x-axis, so it's negative again. All right, well, it's interesting to note, where does it change from positive to negative? It changes at these 4 locations. And if you notice, what's happening is it changes from positive to negative either where the graph crosses the x-axis, in other words, y is 0, or at the vertical asymptote. So what I'd like to do in my problem is go ahead and put 0 on one side of my inequality. So I'll write this as x squared plus 2x minus 3 is less than 0, and then find out when this is positive or negative. Well, I know from my picture what I want to do is find out where is this thing undefined and when is it equal to 0. Well, this is a polynomial. It's never undefined. But it might equal 0, and I can figure out where by factoring. So I'll go ahead and factor this into the quantity x plus 3 times the quantity x minus 1. Now I can see that this thing is going to be equal to 0 at negative 3 and at positive 1. So on my number line, I'm going to mark down those values. So here's negative 3 and positive 1. On my number line, I always like to write why I have them marked on my number line. This time, it's because the expression equals 0. All right, now I see from my graph that on certain intervals, it's always negative. Then on the next interval, it's always positive. So I know that when I break up my number line, my values will always be positive or negative on this interval, and that one. There won't be any changing back and forth. All the changes will occur, if they occur, at those 2 points. So what we're going to do is we're going to take a test point. You're going to pick anything you like less than negative 3, anything on this interval. So let's just try negative 4. So we're going to test negative 4. If I plug negative 4 into my expression, negative 4 plus 3, that's a negative number. And negative 4 minus 1, that's also a negative number. A negative times a negative is a positive number. Let's choose any point you like between negative 3 and 1. For instance, 0. So let's test 0. If I plug 0 into my expression, 0 plus 3, that's a positive number. 0 minus 1 is a negative number. A positive number times a negative number is negative. And remember, I just tested 0, but no matter what point I tested, I would still come up with negative. One more interval to do. Pick anything you like bigger than 1. Let's just try 2. When I plug 2 into my expression, I have 2 plus 3, that's a positive number. And 2 minus 1, that's also a positive number. A positive times a positive is positive. All right, I have my sign chart created. The next thing I want to do is interpret it. I want to know when that expression is less than 0. Remember, less than 0 means negative. So I'm looking at this interval where it's negative. Now, the only other thing I want to consider is what happens at those endpoints. I see that at the endpoints, my expression is equal to 0. I do not want this expression to be equal to 0, strictly less than 0. So I'm going to use parentheses here so that I'm not including negative 3 or 1. this is actually the graph of the solution set. If I want to write the solution set out, I'll just use the interval -3 to 1. I hope that was helpful. Thanks.